Pew Mathematics Paper 2, Wednesday, 14 October 2020. Answer all questions and ensure that your answers to parts of questions are clearly labeled. You should show sufficient working to make your methods clear. Answers without working may not gain full credit. Question number 1. The table below shows corresponding values of x and y for y is equals to square root of x over 1 plus x. The values of y are given to 4 significant figures. Use the trapezium rule with all the values of y in the table to find an estimate for integral from 0.5 to 2.5 square root of x over 1 plus x. Giving your answer to 3 significant figures. Part B. Using your answer to part A, deduce an estimate for integral of 0.5 to 2.5 square root of 9x over 1 plus x. And given that integral from 0.5 to 2.5 square root of 9x over 1 plus x is equals to 4.535 to 4 significant figures, comment on the accuracy of your answer to part B. So we're going to use the trapezium rule formula. I've put the formula at the top there. So we're going to identify the first number y0, y1, y2, y3, y4. And we're going to use the trapezium formula where we would have h divided by 2 and curly brackets y0 plus y4 plus 2 times y1 plus y2 plus y3. y0 is the first term, first value for y. y4 is the last value. So it's the first plus the last plus 2 times the rest. 2 times y1, 2 times y2, 2 times y3. And the value for h is 0.5. And you can get that from the table. 1 minus 0.5 is 0.5. 1.5 minus 1 is 0.5. 2 minus 1.5. Or another way to get h is to use as, if you look at the bottom there, a is 0.5, b is 2.5, and h is given by this formula. So 2.5 minus 0.5 over 4, which gives you 0.5. And when you put h is 0.5 and you sub in the values for y1, y0, y4, y1, y2, y3, it will give you the area is approximately 1.50475. And to 3 significant figure, it will be 1.50. And if you put that in your calculator using the integral, you will get 1.51154. So the answer is slightly different. For part B, we know that the value for 9 there is the difference between what we had the trapezium rule formula to work, well, what we use the trapezium rule formula to work out. So it's square root of 9 times x. So we can take the 9 out and find the square root of 9. Square root of 9 is 3. So you can multiply the previous answer with 3 to get the new value. So 3 times 1.5, it gives you 4.5. And if you use your calculator, you will get 4.5346, which is slightly different from that. And question 1c, the integral of 0.5 to 2.5 square root of 9x over 1 plus x is 4.5. And that 4.5, which is 4.5 to 1 decimal place or 2 significant figure. And the one we are given is 4.535. If we round that to 1 significant figure, to 2 significant figure, or to 1 decimal place, we will get the same 4.5. So to 1 decimal place, or to two significant figures, the answers are the same. And how do we calculate percentage error? You use this formula: approximate value minus exact value divided by exact times 100. And we use this absolute sign because we just want the percentage, not negative values. So 4.535 minus 4.50 divided by 4.535 times 100. That gives us 0.77%. That is accuracy of less than 1%. So the answer is accurate to two significant figure or one decimal place, because to two significant figure or one decimal place, they have the same value. So answer to B is accurate, as 4.535 is 4.50. Relative to a fixed origin, points P, Q, and R have position vectors P, Q, and R respectively. Given that P, Q, and R lie on a straight line, Q lies 1/3 of the way from P to R. Show that Q is equals to 1/3 bracket R plus 2P. So we want to find PQ. PQ is the same as OQ minus OP. The second letter minus the first one. So OQ minus OP, which is Q minus P. PR is equals to OR minus OP. Remember, is the second letter minus the first. So it's R minus P. And QR is OR minus OQ, which is R minus Q. Now, if you imagine PQR on a straight line, PQ is just one part of it, and QR is two parts. So you can see visually that QR is 2 times PQ. And PR from one end to the other end is the same as 3 times PQ. So if you divide that into 3, 1, 2, 3. So each one is PQ. 3 times that is PR from one end to the other end. Now, we have these two equations. QR is R minus Q is the same as 2PQ, which is 2 bracket Q minus P. PR is R minus P is the same as 3PQ, which is 3 brackets Q minus P. We solve these two equations, 1 and 2. To solve it, you do equation 1 divided by 2. So R minus Q divided by R minus P is equals to equation 1, 2 brackets Q minus P divided by 3 brackets Q minus P. If you notice, Q minus P will cancel. So you're left with 2/3. And if you take R minus P to the right-hand side, it becomes times R minus P. So R minus Q is equals to 2/3 times R minus P. Now, we can take minus Q to the right side, take 2/3 R to the left, and take minus 2/3 P to the left. So what you get is Q on its own on the right, and its R plus 2/3 goes to the left, it becomes minus 2/3. Minus 2/3 P goes to the left, it becomes plus 2/3 P. And what you can see here is R minus 2/3 R gives you 1/3 R plus 2/3 P. You can take 1/3 out of the bracket. You're left with R and you're left with 2P. So Q equals to 1/3 bracket R plus 2P. So these are other ways you can do for question 2. You have the equation 1, equation 2, and you can arrange them like that or like that. And you can do the same, and you follow through and you get the same answer. It's just a different way to arrange and do it. Question number 3. 2 log 4 minus x equals to log bracket x plus 8. Show that x squared minus 9x plus 8 equals to 0. So for question 3a, we start with 2 log bracket 4 minus x equals to log bracket x plus 8, and we want to end with this quadratic. So you know where you start, you know where you want to end. So we're going to use this formula, the power law. Log of x to the k to the base a is equals to the k comes in front, it becomes k log x to the base a. So we want to take this 2 to the front. So it becomes log 4 minus x all squared is equal to log x plus 8. We can take out the logs. We got log on the left and log the logs can come out. Now we're left with 4 minus x all squared equals to x plus 8. 4 minus x, we write it twice and multiply it out using FOIL, first, outer, inner, last. So 4 times 4, 16. 4 times minus x minus 4x. Minus x times 4 minus 4x. Minus x times minus x plus x squared. And we take plus x to the left, it becomes minus x. Plus 8 to the left, it becomes minus 8. All equals to 0 now. So what you're left with x squared. 4x minus 4x minus 4x minus x. The ones in yellow, they will end up to be minus 9x. And 16 minus 8 will give you 8. So your answer, x squared minus 9x plus 8 equals to 0. Question 3b says, write down the roots of the equation x squared minus 9x plus 8 equals to 0. You can factorize it, or you can use a calculator, where a, the number in front of x is 1. The number in front of b is minus 9. The number without x, the constant, is 8. And in the calculator, you get the two answers, 8 and 1. So x equals to 1 or x equals to 8. State which of the roots in BI is not a solution of 2 log x 4 minus x equals to log x plus 8, giving a reason for your answer. What we can do is we can start with x equals to 8. If we substitute 8 there, 4 minus 8, it gives you minus 4. And when you find log of minus 4, you put in the calculator, log of minus 4, it gives you non-real error. That means you cannot find it. So 8 is not a solution, as log of 4 minus 8 cannot be found. So that's your complete answer for question 3a and b. Question number 4. In the binomial expansion of a plus 2x to the power 7, where a is a constant, the coefficient of x to the power 4 is 15,120. Find the value of a. So we want to use the binomial expansion formula. I've got the formula written there at the top. And you can use your calculator, or you can use this NCR to simplify. So a plus 2x to the power 7, if we compare it with a plus b to the power n, so that means this a and this a are the same. Our b is the 2x. Our n is the 7. Very important. A is the a. B is 2x plus 2x. And n is 7. Now we want to use that binomial expansion formula to sub in. So a plus 2x to the power 7 gives you a to the power 7, which is your a to the n there, plus 7c1, a to the 7 minus 1, times 2x, which is your b, plus 7c2, a to the 7 minus 2, plus 2x squared, plus 7c3, a to the 7 minus 3, times 2x cubed, and then plus 7c4, a to the 7 minus 4, times 2x to the power 4. and that is the one we want, the one I've colored in yellow. So we want to work out that coefficient, and it says that is equals to 15,120. So we find 7C4. To find 7 combination 4, you can use this formula, or you can use your calculator, and then times it by 2 to the 4 times 7 minus 4 gives you a cube times a cube, and that will be equals to 15,120. So all of that would give us, all of this will give us 560. A cube is 15,120. So to find a, we want to find the cube root. To find a, we find the cube root of 15,120 divided by 560. Put down your calculator, you get a to be equals to 3. Question number 5. The curve with equation y is equals to 3 times 2 to the power x meets the curve with equation y equals to 15 minus 2 to the power x plus 1 at the point P. Find using algebra the exact x coordinate of P. So what we want to do is y equals to 3 times 2 to the x meets y equals to 15 minus 2 to the power x plus 1. So that means they are equal. That means y equals to y, and this expression equals to that expression. So 15 minus 2 to the power x plus 1 equals to 3 times 2 to the power x. So we can have, separate this, it will be 2 to the x times 2 to the 1. So after you separate it, you want to take that to the right hand side. It's minus 2 to the x times 2 to the 1. It becomes plus 2 to the x times 2 to the 1 when you take it to the right. So you're left with 15 is equals to 3 times 2 to the x plus 2 to the x times 2 to the 1. We factorize. 2 to the x is common. So we take 2 to the x out of the bracket. We're left with 3 plus 2. 3 plus 2 is 5. It's times 5 now. We take the times 5 to the left. It becomes divide by 5. 15 divided by 5 is 3. And 2 to the x is left on the right. To solve this, we have to take logs. We put log in front on the left and put log on the right. So log 3 is equals to x log 2. The x comes in front, power to the front law, the power law. X comes in front from x log 2. So it's times. We take log 2 to the left, it becomes divided by log 2. So x is equals to log 3 divided by log 2, or log 3 to the base 2. That's how you get the value for x. So x is equals to log 3 divided by log 2, or log 3 to the base 2. Question 6. Given that x squared plus 8x minus 3 over x plus 2 is equals to ax plus b plus c over x plus 2, find the values of the constants a, b, and c. So for question number 6a, we want to get rid of the x plus 2 in the denominator. So we multiply by x plus 2, x plus 2, x plus 2, x plus 2. So the first x plus 2 will cancel in the first fraction. The next one will be ax times x plus 2, and then the next one b times x plus 2, and it will cancel in the last fraction. So you end up with this expression, this equation. So what you want to do now is, on the right hand side, you want to remove the bracket. Ax times x gives you ax squared. Ax times 2 gives you 2ax. B times x will give you bx. B times 2 will give you 2b, and there's a plus c. Now we put the x together, 2a plus b, and x is a common factor, it stays out of the bracket. So we want to compare like terms. 1 is equals to a, that's the coefficient of x squared, a is 1. 2a plus b is equals to 8, that's the coefficient of x, what is in front of x. And 2b plus c is equals to minus 3. So from there, we got a is 1. And substituting a is 1 in there. 2 times 1 plus b equals a. That gives b is 6. And 2b plus c is minus 3. We know b is 6. We substitute 6 in there. And that will give c to be minus 15. So your three numbers are a is 1, b is 6, and c is minus 15. For part B, it says we should integrate that expression. So we start there, and that's where we want to end. Since we had changed it to partial fractions, we know a is 1, b was 6, and c was minus 15 from part A. We can write it out like that. Now we can integrate x. When you integrate x, you get x squared over 2. You add 1 to the power and divide by the new power. 6, when you integrate 6, you get 6x. When you integrate 15 over x plus 2, you can take 15 out of the bracket. It becomes integral of 1 over x plus 2. Integral of 1 over x gives you ln x plus 2, and then there's times 15. So you get 15 times ln x plus 2. And don't forget the minus. Now we need to, there's the limit from 0 to 6. We substitute in 6. 6 will go in there first, and you go there, and you go there. And that gives you 18 plus 36 minus 15 ln 8. After that, 0 will go there, and 0 will go there, and 0 will go there. So you get 0 plus 0 minus 15 ln 2. Now we can remove the bracket. So 18 plus 36 minus 15 ln 8. Minus and minus will become a plus. Plus 15 ln 2. 18 plus 36 gives you 54. 15 ln 2 can come in front. It becomes 15 ln 2 minus 15 ln 8. 15 is common, so you take it out of the bracket to factorize. So you get ln 2 minus ln 8. When you subtract logs, you divide them, so it becomes ln 2 divided by 8. And 2 divided by 8 is 1 over 4. And 1 over 4 is 1 over 2 squared, which is 2 to the minus 2. So the 2 to the minus 2 can come to the front. It becomes minus 2 times 15. It becomes minus 30. So it becomes 54 minus 30 ln 2. So A is 54, B is minus 30. Important part, this part here. Ln of 2 over 8 is ln of 1 over 4, which is the same as ln of 1 over 2 squared, because 2 times 2 is 4. And 1 over 2 squared is the same as 2 to the minus 2 is ln 2 to the minus 2. The minus 2 comes in front, and multiply with the 15 to get minus 30. Question number 7. Figure 1 shows a sketch of the curve C with equation y equals to 4x squared plus x over 2 root x minus 4 ln x. Show that dy over dx is equals to 12x squared plus x minus 16 root x divided by 4x root x. So to do question 7, we want to identify this is where we start and this is where we want to end. So we have y at the start. We want to get dy over dx at the end. So we want to differentiate. We look at what we want to differentiate. I'm going to use the quotient rule to differentiate it. So that's the formula for the quotient rule. And another thing which you need to remember, when you differentiate y equals to ln x, you get 1 over x. So to use the quotient rule, we're going to have 4x squared plus x be equals to u, the numerator, and 2 root x is equals to v, the denominator. So we differentiate u, du over dx, differential of 4x squared, it gives you 8x. Differential of x, it gives you 1. 2 root x, we can write it as 2x to the power half. When you differentiate 2x to the power half, the half comes in front, and you minus 1. So it becomes half times 2x to the minus a half. Half times 2 will give you 1. So it's x to the power minus a half. Now we put that into the formula, the quotient rule formula. So we have v, which is 2x to the half. That goes there, and that's for the v. Du over dx, that's du over dx, which goes next. Minus goes next. U, which is 4x squared plus x, it goes next, times dv over dx, which is x to the power minus a half, all divided by v squared. V is 2x to the half, you put it there and you square it. All we have done is substitute. Now we want to remove the brackets. 2 times 8 gives you 16. X to the half times x to the 1. 1 plus a half gives you 3 over 2. 2x to the half times 1, it gives you 2x to the half. This is like minus 1 times 4x squared. It gives you minus 4x squared. But when you multiply that with the x to the minus a half, so you have minus a half plus 2, it gives you 3 over 2. So it's minus 4x to the 3 over 2. And x times x to the minus a half, this is like x to the 1. 1 minus a half, it gives you a half. So it becomes minus x to the half. All divided by, this would be 2 squared would be 4. X to the half squared is x. X to the half times x to the half. You add the half together, half plus half is 1. So it becomes just x. And what we need to do now is differentiate 4 ln x. We just differentiate ln x and times by 4. When you differentiate ln x, you get 1 over x. So it's 4 times 1 over x. 4 times 1 over x is 4 over x. So minus 4 ln x, when you differentiate, it becomes 4 over x. Now you can put these two fractions together as 1. With a common denominator of 4x, you will get 4 times, with a common denominator of 4x, it would get you 12x cubed, 12x to the power 3 over 2 plus x to the 1 over 2 minus 16 over 4x. So now that is our answer, but we want to change it to look like what it says in the question. So what can we do? We want to get 12x squared. What do we times 3 over 2 by to get x squared? If we times by x to the half for all of them, so we will multiply 12x to the 3 over 2 times x to the half plus x to the half times x to the half minus 16 times x to the half over 4x times x to the half. So we times all of them by x to the power half. It keeps everything the same. It hasn't made a big change. So what we're going to do is, when we multiply x to the half times x to the half, half plus half gives you 1. 16 times x to the half, we can just write it as 16 times square root of x. And 4x times x to the half, it will give you 4x to the 3 over 2. Or you can just write 4x and then x to the half. So that is what you would get. And when you add 3 over 2 plus a half, it's like 1.5 plus a half. That gives you 2, which is x squared. So you've got the dy over dx to be 12x squared plus x minus 16 with x over 4x with x. Quod erat demonstratum as required to show. The point P shown in figure 1 is the minimum turning point on C. Show that the x-coordinate of P is a solution of x equals to 4 over 3 minus root x over 12 all to the power 2 over 3. So we have got that expression for dy over dx. So what we do is, if we take 4x root x cross multiply over there times 0, that would be 0. So what we want to do, we want to set the numerator equals to 0 and divide by square root of x. So we have 12x squared plus x minus 16 root x, which is that numerator. If we divide everything by square root of x, divide by square root of x, that will still be 0. What would happen is square root of x can come to the top, it's become x to the minus a half. Comes to the top, x to the minus a half. And this square root of x will cancel. So you're left with 16. 2 minus a half is 3 over 2. 1 minus a half is a half. So you have 12x to the 3 over 2 plus x to the half minus 16 equals to 0. So what we want to do next is to make the term with x to the 3 over 2, this one I've put in yellow, we want to make that the subject of the formula. We want to make this x in yellow, the one I put in yellow, the subject of that formula. So we start by taking minus 16 to the right, it becomes plus 16. We take plus x to the half to the right, it becomes minus x to the power half. It's times 12. We take it to the right, it becomes divide by 12. And 16 divided by 12, you divide by 4, it gives you 4 over 3. So x to the 3 over 2, we just want to get x. So we want to remove 3 over 2. What's the inverse of the power 3 over 2? Is the power 2 over 3. If we have 3 over 2, we take it to the other side, the power will change to 2 over 3. So it will be 4 over 3 minus square root of x over 12 to the power 2 over 3. Question 7c. Use the iteration formula. Find the value of x2 to 5 decimal places and the x-coordinate of p to 5 decimal places. So when you want to use the iteration formula, we can start with n is equals to 1. So if 1 goes there for n, 1 plus 1 becomes 2, so we get x2. So x2 would be 4 over 3, stays the same. Square root of n, since n is 1, we want to put x1 there, and x1 is 2. So x1 is 2, which we put square root of 2 divided by 12 to the power 2 over 3. And if you put all of that in your calculator, if you look there, I've taken a screenshot of the calculator. You put that in your calculator all at once. Careful, put the brackets. You get 1.13894 to 5 decimal places. To 5 decimal places. So you round it to 5 decimal places. And the second part of 7 says the x-coordinate of p to 5 decimal places. You can deduce that it is 1.15650. And I'll show you on the graph how that works. If you put that equation, 12x to the power 3 over 2 plus x to the half minus 16 equals to 0, that's the equation where we made x the subject in the iterative formula. If you put that in the equation solver in your graphics calculator, so that is your 12x to the power 3 over 2 plus x to the half minus 16 equals to 0, it would give you 1.15650 to 5 decimal places. And that is what you do to show it. So in your graphics calculator, you would go into F3 equation solver to help you to do that. So that's the first part of question 7a. And this shows completion of 7a and the first part of 7b. And this shows 7c, part 1 and part 2. And this shows how you can use the equation solver to solve that equation. A curve C has equation y equals to f of x. Given that f dash of x is equal to 6x squared plus ax minus 23, where a is a constant, the y-intercept of C is minus 12. X plus 4 is a factor of f of x. Find in simplest form f of x. So we know what f dash of x is. Now to get f of x, we integrate f dash of x. So when you integrate, you get back to the function. So you integrate 6x squared plus ax minus 23. Integration, add 1 to the power, 2 plus 1 will give you 3, and you divide by the 3. So 6x cubed divided by 3. Ax to the power 1, add 1 to the power, it becomes 2, and divide by the 2. And when you differentiate a number on its own, you just add x. And then plus c, the constant of integration. So that's what f of x is. But it tells us that c is minus 12. So we put in minus 12 for c. So we write it out with adding c and minus 12. Now 6 divided by 3, it gives you 2. So we write it out in this simplified form. It also says x plus 4 is a factor of f of x. That means if you put f of minus 4, it will be 0. So what we want to do is we have the 2, we put minus 4 cube plus a half a minus 4 squared minus 23 times minus 4 is equal to 0. And when you do solve that, you get minus 128 plus 8a plus 92 minus 12 equals to 0. So when you solve that, 8a will be equals to 48 and a would be equals to 6. Now you sub in a as 6. So your function f of x is 2x cubed. 6 divided by 2 is 3, 3x squared minus 23x minus 12. That's what f of x is. So that's your complete answer for question number 8. Question number 9. A quantity of ethanol was heated until it reached boiling point. The temperature of the ethanol, theta degrees Celsius at time t seconds after heating began, is modeled by the equation theta is equals to a minus b e to the minus 0.07 t, where a and b are positive constants. Given that the initial temperature of the ethanol was 18 degrees Celsius, after 10 seconds, the temperature of the ethanol was 44 degrees Celsius. Find a complete equation for the model, giving the values of a and b to 3 significant figures. So we want to substitute t is equal to 0 and theta equals to 18, and t is equals to 10 and theta equals to 44 to obtain 2 equations connecting a and b, and then proceed to solve these equations in a and b simultaneously to get values for both constants. So substituting t is equals to 0 and t equals to 18, that would give us, and theta is 18. Theta is 18 and t is 0. So that will give us 18 is equals to a minus b, and we call that equation 1. Substitute t is 10 and theta is 44. That will give us 44 equals to a minus b e to the minus 0.7. To solve these two equations, equation 2 minus 1. 44 minus 18 is 26. A minus a is 0. And minus b e to the minus 0.7 minus b, you would get the minus and minus will become a plus. And b is common, you take it out of the bracket. So you have minus e to the minus 0.7 plus 1 is equals to 26. And what you want to do next is take all of that together to the left side. Because it was times, it becomes divide. So 26 divided by minus e to the minus 0.7 plus 1. That will give you 51.647. So B is 51.6 to 3 significant figure. Since A 18 minus 18 is equals to A minus B, so A is equals to 18 plus B. Take the minus B to the right, it becomes plus. So 18 plus 51.6472, that gives A to be 69.64, which is 69.6, 3 significant figure. So you can write it as theta is equals to 69.6 minus 51.6 times e to the minus 0.07t. Ethanol has a boiling point of approximately 78 degrees Celsius. Use this information to evaluate the model. You can identify A as the boiling point, maximum or minimum temperature in the model. So what we can do is we can substitute that 78 for theta. So 78 minus 69.6 divided by 51.6, it will give us E is equal to minus 0.07t. That will give us minus 7 over 43. And if you want to solve it, you have to take logs. Ln of minus 7 over 43 is equal to ln E to the minus 0.07t. But the equation cannot be solved. You cannot take log of a negative number. So the maximum temperature is 69.6 degrees Celsius according to the model. The model has an upper limit of 69.6. So what do we conclude? The model is not appropriate, as 69.6 degrees Celsius is much lower than 78 degrees Celsius. And here, if you try to get natural log of a negative number, it will give you an answer with pi and I, a complex number. But that is if you set your calculator into complex mode. But if it is not in complex mode, if it is in complex mode, you will get this answer. A plus B is complex mode. If it is in real mode, it's a non-real error and you wouldn't get an answer. That's your answer for question 9 part A and the answer for question 9 part B. Question number 10. Show that cos 3A is identical to 4 cos cube A minus 3 cos A. So we're going to use this formula at the top, cos A plus B, and we're going to use this double angle formula. So we want to write cos 3A as 2A plus A, because 2A plus A is 3A, 2A plus A. And now using that, it becomes cos 2A cos A minus sine 2A sine A. Now we can change cos 2A into 2 cos squared A minus 1. And the cos A stays the same. We can change sine 2A to 2 sine A cos A. And the sine A at the end stays the same. So now we have 2 cos squared A minus 1 cos A minus 2 cos A sine squared A. Where did this sine squared come from? We multiply sine A times sine A. That gives us sine squared A. But we know sine squared A is 1 minus cos squared A. So we replace sine squared A with 1 minus cos squared A. And you can see a pattern. We don't want to have sine. We're replacing sine. So you end up with an answer without sine. So sine squared A is 1 minus cos squared A, which is replaced there. That replaces sine squared A. So that's the equation now that you have. So 2 cos squared A times cos A it gives you 2 cos cube A. Minus 1 times cos A, it gives you minus cos A. Minus 2 cos A times 1 gives you minus 2 cos A. And minus 2 cos A times minus cos squared A, the 2 and the 1 will make 3. So it gives you 2 cos cube A. Now we add 2 cos cube A plus 2 cos cube A. It gives you 4. 2 plus 2 gives you 4 cos cube A. Minus cos A minus 2 cos A is like minus 1 minus 2. Be minus 3 cos A. Quod erat demonstratum, as required to show. Question 10b, hence solve between minus 90 and 180 the equation 1 minus cos 3x equals to sine squared x. So we want to replace, instead of cos 3x, we replace it with this 4 cos cube A minus 3 cos A, because we got that from part A, and we're using this word hence. Use your answer from part A. That's what hence means. Replace cos 3x with 4 cos cube A minus 3 cos A. So you will get 1 minus 4 cos cube x minus 3 cos x equals to sine squared x. But sine squared x is 1 minus cos squared. So we replace that sine squared with 1 minus cos squared. So 1 minus 4 cos cube x plus 3 cos x equals to 1 minus cos squared x. Now there's this 1 on the left and there's this 1 on the right. They can cancel each other. 1 minus 1 is 0. You're left with minus 4 cos cube x plus 3 cos x. And you take the minus cos squared x to the left, it becomes plus cos squared x. You can times by the minus 1. So this minus becomes a plus, this plus becomes a minus, and this plus becomes a minus, equal to 0. Cos x is found in all three of them. So you take cos x out of the bracket, factorize. So you got cos x there. And you'll be left with 4 cos squared x minus cos x minus 3. The cos x comes from there, and the 3 comes from there, equal to 0. When you factorize this, it's like factorizing 4x squared minus x minus 3. So you can use your calculator to factorize that. So when you factorize, either x is equals to 0, first one, or when you factorize that, you get x equals to minus 4 over 3 and x equals to 1. And that's how you put it in the calculator. 4 goes there, minus 1 goes there, minus 3 goes there. You get your two answers. So cos x, you want the answers between minus 90 and 180. So cos x equals to 0. That means x is minus 90 or x is 90. Cos x equals to minus 0.75. And inverse cosine of minus 0.75 is 138.59. So x is 138.59. Cos x is equals to 1. That means inverse cosine of 1 is 0. So all your four answers are minus 90, 0, 90, and 139. When you round 138.59, you get 139. And if you plot your graph of y equals to cos x, when x is 138.59, y is minus 0.7. You can see there. And you can use this for the view window to change the x and the y values. So that's your answer for question 10A. And that's your answer for question 10B. Figure 2 shows a sketch of the graph with equation y equals to 2 absolute value of x plus 4 minus 5. The vertex of the graph is at the point P shown in figure 2. Find the coordinates of P. And part B, solve the equation. So the coordinates of P are minus 4 and minus 5. which you can see there on the graph. If you put that in your calculator, gives you -4 and -5. So that is the function they have put in the calculator. 2, and make sure you get the absolute sign, x plus 4 minus 5. And you put the view window from -10 to 10, -10 to 10. Use standard. It would show you, and you go to GSolve, and you would find x is -4 and y is -5. 11b says solve the equation. We've got the left-hand side and we've got the right-hand side. So we can plot the left-hand side in that red there, and we can plot the right-hand side in the blue. And you can see where they meet. They meet at x equals to -10.6. That's your answer. Now we have to show it algebraically, but that's the answer where they meet, and you can see it. So you can see I've put them in the calculator there. The blue one is the right-hand side. The red one is the left-hand side. And that's the view window so that you can see it clearly. Those are the numbers you use. The way you solve it is to get rid of this absolute sign. You will use the minus version first. So you put minus in front of the 2, bracket x plus 4, bracket -5. So it will be remove the bracket. -2 times x is -2x. -2 times 4 is -8, and then -5. So -2x goes to the left. It becomes +2x. So 3x plus 2x gives you 5x. Plus 40 goes to the right. -8 minus 5 is -13. Minus the 40 gives you -53. It's times 5. You take it to the right, it becomes divided by 5. -53 divided by 5, it gives you -10.6. So you have seen the answer with the calculator, and then you've done algebra to prove it. Part 11c says find the range of possible values of a. Write your answer in set notation. So if y equals to ax intersects y equals to 2 absolute value of x plus 4 minus 5. So we want to solve ax is equals to 2 bracket x plus 4 minus 5. So we can have ax is equals to 2x plus 8. You remove the bracket. 2 times x is 2x. 2 times 4 is 8. So ax is equals to 2x plus 8 minus 5 is 3. Now you take 2x to the left. It becomes -2x. So ax minus 2x equals to 3. X is common. So you take x out of the bracket. You're left with a minus 2. And it's times a minus 2. You take it to the right. It becomes divided by a minus 2. So x is 3 divided by a minus 2. You don't want to divide by 0. 3 divided by 0 is an error on your calculator. So you don't want the denominator to be 0. So a minus 2 should be bigger than 0. So you can say a is bigger than 2. If you use the negative one, instead of +2, you use -2. Because when you remove this absolute sign, you use the positive and the negative. So we've used the positive for 2, and now we'll have to use the negative for 2. So the -2 times x is -2x. -2 times 4 will be -8. So -8 minus 5 is -13. -2x goes to the left. It becomes +2x. So ax plus 2x is equals to -13. X bracket a plus 2 equals to -13. X is equals to -13 divided by a plus 2. So if you don't want this to be 0, a plus 2 cannot be 0. So that means a should not be -2. Because if it's -2, -2 plus 2 is 0, and -13 divided by 0 is an error on your calculator. So a cannot be -2. That's the answer for question 11a. That's the answer for 11b. And that's the answer for 11c. Question number 12. The curve shown in figure 3 has parametric equations. X equals to 6 sine t and y equals to 5 sine 2t. The region R, shown shaded in figure 3, is bounded by the curve and the x-axis. Show that the area of R is given by integral from 0 to pi over 2, 60 sine t cos squared t dt. So for question 12, what we want to do is we want to find dx over dt. When you differentiate 6 sine t, the 6 stays the same, and when you differentiate sine t, you get cos t. Now, this is, you can use this formula for finding the area when you have equations given in parametric form. So it's integral of the y of t times the dx over dt. So you integrate the function y of t times the differential of x. So we will have y times dx over dt. Y is 5 sine 2t. Y is 5 sine 2t. Dx over dt is 6 cos t. When you multiply that, 5 times sine 2t, you can write it as 2 sine t cos t. Double angle formula. So 5 times 2 times 6. 5 times 2 times 6. 5 times 2 is 10. 10 times 6 is 60. That's how we got the 60. And sine t times cos t times cos t. Cos t times cos t will give you cos squared t. So that's how we got 60 sine t cos squared t. And we're integrating from 0 to pi over 2. The 12a part 2 is say, hence show by algebraic integration that the area of R is exactly 20. So to integrate an expression of the form integral of k f of R and then x, f of x to the power n, try f of x to the n plus 1. Remember we have n there, we try with power n plus 1 and differentiate to check and then adjust any constant. So we will try the n plus 1 there, try 2 plus 1, which gives you 3. So 2 plus 1, it gives you 3. So when you differentiate cos cube t, you will get that expression there. So what you want to do is you want to adjust it, what you will do to differentiate that to get that side. So now the integral will be minus 20 cos cube t, because the 3 comes and multiply 3 times 20. That will give you the 60. And when you differentiate cos, you get minus. So the minus with that minus will become a plus. So that's why you have minus 20 cos cube t. And you're integrating from 0 to pi over 2. So you substitute pi over 2. So pi over 2 goes in. And don't forget it's cube. Put the cos pi over 2 all cube times minus 20. And you substitute the 0. It's cos 0 all cube times minus 20. Cosine of pi over 2 times minus 20. This will give you 0. And minus will be plus. Cos 0 is 1. 20 times 1 will be 20. So the area would be 20. It says part of the curve is used to model the profile of a small dam, shown shaded in figure 4. Using the model and given that x and y are in meters, the vertical wall of the dam is 4.2 meters high. There is a horizontal walkway of width mn along the top of the dam. Calculate the width of the walkway. We are given that y is equals to 5 sine t, and y represents that vertical height, or the y-axis. So they've told us that is 4.2. So we take this 4.2, replace it for y there. Very important. The 4.2 meters is the vertical wall, and that 4.2 replaced for y. So we have 4.2 is equals to 5 sine 2t. Now it's times 5. We take it to the left, is divided by 5. So sine 2t is 4.2 divided by 5. Now we want to find the inverse sine. If you take sine to the other side, it becomes inverse sine of 4.2 over 5. And make sure your calculator is in radians. So inverse sine of 4.2 over 5 would be 0.997283. But sine is positive in the first and second quadrants. So if you look at the cast diagram there, sine is positive in the first and the second quadrant. So in the first quadrant is 0.9972. In the second quadrant is pi minus 0.9972. So when we want to get t, it's times 2. Opposite of times 2 is divided by 2 there. That will give you 0.4986. And with this times 2, so we divide by 2 there as well. So that will give us 1.072. So we've got the two values of t. So we want to find the x values at both values of t. And we know x is equals to 6 sine t. So we start with the first value for t, 0.4986. So it would be 6 sine 0.4986. And 6 times sine 0.4986 would give you 2.8693. That's your first value for x. And we use the same x equals to 6 sine t, 6 sine 1.072, and 6 times that would be 5.269. So the width of the path is the 5.269 minus the 2.869. And that will give us 2.40 meters. So we know the x value when t is 0.49 and x value when t is 5.269. When we subtract them, it gives us the width of the path of 2.40 meters. So that's your first part of question 12, 12a, part I. That's 12a, part 2I. That's the first part of 12b. And the final part of 12b. Question number 13. The function g is defined by g of x is 3 ln x minus 7 over ln x minus 2, where k is a constant. Deduce the value of k. So it says that x should not be equals to k. So we look at the denominator. You cannot divide by 0. So we don't want ln x minus 2 to be 0. Imagine dividing a number 2 divided by 0. Put it in your calculator, see what you get. So whatever is at the top, if you divide it by 0, you wouldn't get an answer. So you don't want ln x minus 2 to be 0. You change ln x means the natural log. So it's log x to the base e minus 2 equals to 0. If you take the minus 2 to the right, it becomes plus 2. So it becomes e to the power 2, e squared is equals to x. So k is equals to e squared. Or you can say you don't want x to be e squared. Part B, prove that g dash of x is greater than 0 for all values of x in the domain of g. So we know g of x. We're going to use the quotient rule, and I've put the quotient rule down there for you to see. I'm going to use that rule. So we're going to let u be the top one, u be 3 ln x minus 7, v be the denominator, ln x minus 2. Now du over dx, the 3 stays the same. Differentiate ln x, you get 1 over x. So 1 over x times 3 is the same as 3 over x. So it's 1 over x times 3 is 3 over x. When you differentiate ln x, you get 1 over x, and you differentiate minus 2, you get 0. Now we put them together in the quotient rule formula. So we have v times du over dx minus u times dv over dx all over v squared. So v times du over dx minus u times dv over dx all over v squared. Now, we can take 1 over x out of the bracket. So we have 1 over x there. So we'll be left with 3 ln x minus 2. And we'll be left with 3 ln x minus 7. So 3 ln x minus 3 ln x will be 0. This will cancel with that. 3 times minus 2 is minus 6. Minus and minus will become plus. So it's minus 6 plus 7. It gives you 1. So all that is left in this bracket is 1. So it's 1 over x times 1, which is 1 over x. So it is left now 1 over x at the top divided by ln x minus 2 squared. You can write it like that, 1 over x divided by ln x minus 2 all squared. And when you divide, you change it to a times and flip this fraction. So the 1 goes to the top and the ln x minus 2 squared comes below. So you would end up with 1 over x bracket ln x minus 2 all squared. And you notice that the question says x is bigger than 0. So this one is bigger than 0. And notice that ln x minus 2 is squared. So whenever you square a number, it's going to be ln x minus 2 squared will be bigger than 0. So hence g of x is greater than, g dash of x is greater than 0. For 13c, find the range of values of a for which g of a is bigger than 0. So let's look at the top, the numerator. 3 ln x is bigger than 0. Minus 7 goes to the right, it becomes plus 7. Times 3 goes to the right, it becomes divided by 3. So ln x is greater than 7 over 3. And you can use log x to the base e is greater than 7 over 3. So e to the power 7 over 3. So x is greater than e to the power 7 over 3. So that's our a. Or a is greater than e to the 7 over 3. And if we do the same for the denominator, ln a minus 2 is greater than 0. We've just replaced the x with a. Replace x with a. So minus 2 goes to the right, it becomes plus 2. So log a to the base e is equals to 2. So e to the power 2 or e squared, a is greater than e squared. So what you have is between 0, a and e squared, and a is greater than e to the 7 over 3. So those are the range of values. So if you look at this, you will notice that e to the 7 over 3 is this value there. E to the 7 over 3 is this value there, which is, it's marked there. And it goes from 0 up to e squared. So e squared is a value somewhere here. So from 0 up to e squared, and then from e to the 7 over 3, from here upwards. Those are the parts where it is positive, where it is greater than 0. And you can work out e to the 7 over 3 is 10.31. So from this point, 10.31 is positive. It's a bigger number than 0. It's bigger than 0. So that's what you get there. And e squared is 7.3. E squared is the same as 7.3, which 7.3 will be somewhere there. So between 0 and 7.3, it's above the x-axis. And then it skipped, and then it starts again from 10.31. 3, 1 to be above the x-axis. So you can see that if you choose a number just slightly below 7.3, a number just slightly below e squared, like e squared minus 0.9 or something, it would give you an answer which is above the x-axis. And if you choose a number bigger than e to the 7/3, it will be above. So this is above the x-axis, and this is above the x-axis, and this is below the x-axis. So that's question 13A, question 13B, and question 13C. Question number 14. A circle C with radius r lies only in the first quadrant, touches the x-axis and touches the y-axis. The line L has equation 2x plus y equals to 12. Show that the x-coordinates of the points of intersection of L with C satisfy 5x squared plus 2r minus 48 bracket x plus r squared minus 24r plus 144 equals to 0. The equation of a circle with center AB and radius r is given by x minus a all squared plus y minus b all squared equals to r squared. We're going to use that equation. So the center is AB and the radius is RR because they both touch the x and the y axis. So the radius is R, the center is AB. So the center is RR because A is equals to B and the radius is R. So in that equation for a circle, we'll put A to be R and B to be R. So it's x minus r squared plus y minus r all squared equals to r squared. For the equation of the line, 2x plus y equals to 12. We make y the subject. We take 2x to the right, it becomes minus 2x. So y equals to 12 minus 2x. Now we got two equations, circle and a line to solve. So we take the equation of the line, substitute it in the equation of the circle, we replace y. So instead of y, we will put 12 minus 2x. We'll sub 12 minus 2x for y. So we'll have x minus r all squared. This one stays the same. Instead of y, we'll put 12 minus 2x. And the minus r stays the same. And then all squared equals to r squared. When we expand x minus r all squared, we would get x squared minus 2xr plus r squared. And we want to expand 12 minus 2x minus r in bracket 12 minus 2x minus r. So if you follow those lines with the colors I've put there, 12 times 12 will give you 144. 12 times minus 2x minus 24x. 12 times minus r gives you minus 12r. So you follow the other line, minus 2x times 12 minus 24x, and so on, until you get the complete expression like that. Be careful with the signs. Now we want to put them together. Minus 24 minus 24, it gives you minus 48x. So the 144 stays the same. The minus 24 and minus 24 becomes minus 48x. Plus 2xr plus 2xr becomes 4xr. And the 4x squared stays the same. And the r squared stays the same. Now, when we put that in the whole equation from before, so we have that x squared minus 2xr plus r squared. And this comes from that x minus r all squared, which we did up there. And then we put all of this 144 minus 48, all of this equals to r squared. Now, r squared on the left would minus with r squared on the right. So that will become 0. If you take plus r squared to the right, it becomes r squared minus r squared, which is 0. That disappears. Now, if we take x squared plus 4x squared, it gives you 5x squared. And 144 stays the same 144. And minus 24r, and do we have another minus 24r? Okay, let's look at the minus 24r is minus 24r there. And 2xr minus 2xr plus 4xr, it gives you minus 2xr. So you get the new expression or equation. The 5x squared stays the same. 2xr and 48xr, they all have x in them. So this x can come out of the bracket, and you have 2r minus 48. And then you're left with this r squared minus 24r plus 144 equals to 0. So you've got r squared plus 2r minus 48 bracket plus r squared minus 24r plus 144 equals to 0. Question 14b. Given also that L is a tangent to C, find the two possible values of R, giving your answers as fully simplified surds. So we can treat all of this as a quadratic. So A, we can treat it like ax squared plus bx plus c equals to 0. So A is 5, B is 2r minus 48, and C is r squared minus 24r plus 144. And because it says a tangent, that means b squared minus 4ac should be equals to 0. Because a tangent touches at one point. So b squared minus 4ac equals to 0. So we want b squared is 2r minus 48 all squared minus 4 times a is 5 times c is r squared minus 24r plus 144. So we want to multiply 2r minus 48 times 2r minus 48. That will give us 4r squared minus 96r minus 96r plus 2,304. Minus 4 times 5 is 20. And it has to be 20 times that. So we would want to put 4r squared and 20r squared. 4 minus 20 is minus 16, because when you remove the bracket, that will be minus 20r squared. Minus 20 times 24 would be 480 plus 480r. And minus 20 times 144 would be minus 2880. So have 4r squared minus 20r squared, that gives you 16r squared, minus 16r squared. Minus 96 minus 96 plus 480 will give you 288r. And 2304 minus 2880 will give you minus 576. And if you divide all of them by 16, you get r squared minus 18r plus 56 equals to 0. And you can use the quadratic formula. X is equals to minus b plus or minus square root of b squared minus 4ac divided by 2a. You can use the quadratic formula. You get r is equals to 9 plus or minus 3 root 5. If you want, you can use your calculator, where a is 1, b is minus 18, C is 36, and your calculator would give you 9 plus 3 root 3, and when you press execute again, it will give you 9 minus 3 root 3. So that's the first part for question 14a. That's the second part for question 14a. That's the first part for question 14b. And that's the final part for question 14b. Question 15. A geometric series has common ratio r and first term a. Given that r is not equals to 1 and a is not equals to 0, prove that Sn equals to a bracket 1 minus r to the n over 1 minus r. So we have the geometric formula. So the first term is a, second term is ar, the third term is ar squared, and the n term is ar to the n minus 1. Suppose we multiply by r. So we times this by r, times this by r, times this by r, times this by r, times this by r. So this will become r Sn. The first one will become ar, because you times by r. The second one will become ar squared. Third one will become ar cubed, because you've times by r. The last one will become arn, because n minus 1 times r, this would cancel. You end up with ar to the n. So it's like saying ar to the n minus 1 times r to the 1. The r and this would cancel. So you're left with ar to the n. Now, you got two equations, equation 1 and 2. Equation 1 take away 2. So Sn take away Rsn. So what will happen is the AR will minus the AR be 0. The AR squared will minus the AR squared, it will be 0. Whatever is there would minus the AR cube, will be 0. AR to the n minus 1 will minus AR to n minus 1. So what you will be left with is A and AR to the n. So that means Sn minus Rsn is equals to A minus AR to the n. We can factorize S out. This is like Sn times 1. So Sn can come out, and you're left with 1 minus R. This is like A times 1. A can come out, and you're left with 1 minus R to the power n. Now you want to get Sn is times 1 minus R. You divide by 1 minus R. Take that to the right, it becomes divide. So your Sn is equals to A bracket 1 minus R to the n over 1 minus R. So that is the formula. Quod erat demonstrantum, as required to show QED. Question 15. Given also that S10 is 4 times S5, find the exact value of R. So the sum of the first 10 terms is equals to 4 times the sum of the first 5 terms. So we write down the formula for sum of the first 10 terms. A bracket 1 minus R to the 10, because n is 10, or 1 minus R, is equals to 4 times A bracket 1 minus R to the 5, because it's 5 terms, over 1 minus R. So we look on the left-hand side and look on the right-hand side. What can we cancel out? 1 minus R on the left cancel 1 minus R on the right. So we are left, and then A will cancel on the left, A will cancel on the right. So we're left with 1 minus R to the 10 and 4 bracket 1 minus R to the 5. Now we can remove the bracket. 4 times 1 is 4. 4 times minus R5 is minus 4R to the 5. What we want to do, we want to take everything to the right. Minus R10 goes to the right, it becomes plus R10. And 1 goes to the right, it becomes minus 1. So you get R10 minus 4R5 plus 4 minus 1 equals to 0. 4 minus 1 gives you 3. Now you want to solve this. This is a disguised quadratic. What I mean is, if you make r root to the 5 as x, that means r root to the 5 all squared is x squared. So you can write it as x squared minus 4x plus 3. Factorize to get x minus 1, x minus 3. So x is equals to 1 or x equals to 3. Now replace x with r root to the 5. R root to the 5 is 1. So r is the fifth root of 1, which is 1. And we ignore that or reject this answer. R is equals to, r root to the 5 is equals to 3. R is the fifth root of 3 is the answer we want, because the question says given that r is not equals to 1 in the question. That's why we reject r equals to 1. So that's your answer for 15A. And that's your answer for 15B. Question number 16. Use algebra to prove that the square of any natural number is either a multiple of 3 or one more than a multiple of 3. So any natural number can be expressed in the form 3k, 3k plus 1, 3k plus 2, or equivalent like 3k minus 1, 3k, 3k plus 1. So let's use the one I've put in yellow. Square any two distinct cases of the above. So we have 3k squared. 3 times 3 is 9. K times k is k squared, so gives you 9k squared. 9 is the same as 3 times 3. So it's the same as 3 times 3k squared, which is a multiple of 3. When you multiply by 3, you get a multiple of 3. Like 3 times 1, 3 times 2, 3 times 3. As long as you multiply by 3, it's a multiple of 3. Now let's do the next one. 3k plus 1 all squared will give us 9k squared plus 6k plus 1. 9 is the same as 3 times 3. 6 is the same as 3 times 2. So we can factorize. That's 3 times 3, 3 times 2. So we can take out 3 from those two, and you're left with 3k squared plus 2k plus the 1. So this is because 3 times 3k squared is 9k squared, and 3 times 2k is 6k. So what's happening here is this is a multiple of 3 plus 1. And Wuhan is 1 more than a multiple of 3. That's 1 more. So 3k plus 2 all squared. When we write this out and multiply it, 3k plus 2 times 3k plus 2, it gives us 9k squared plus 12k plus 4. 9 is 3 times 3. 12 is 3 times 4. So we can take 3 out, and it left with 3k squared plus 4k plus 1. Because 4 is the same as 3 plus 1. So we can take 3 out. So 3 times 3 is 9k squared. 3 times 4 is 12k. 3 times 1 is 3. Plus this 1, it gives you that 4. So this is plus 1 at the end. Now, if you use 3k minus 1 squared and write it twice and multiply it out, 3k minus 1 times 3k minus 1, we will get 9k squared minus 6k plus 1. 9k is the same as 3 times 3k squared, and 3 times minus 2k is minus 6k plus the 1 is 1 more than the multiple of 3. So as long as you successfully show for all 3 cases that the squares are either a multiple of 3, like the first one, multiple of 3, or 1 more than a multiple of 3 using algebra, that's 1 more. You get your multiple of 3, all your multiples of 3, and then you add 1. So that's what 1 more than a multiple of 3. And that 1 is a multiple of 3.